I did. Okay. So what was the project? Actually?
Vending machine kalau tak silap. Vending machine, yeah.
Okay. All right. So this is the class of system design, yeah? This is the class of system design, and actually this is the last course in design series. Okay. Before we start, I need to tell you that I teaching you today. Okay, for this I teach you today. Okay, I cover one topic, and starting from next week, okay, I'm going to take leave for a few weeks, and Dr. Jamaluddin Muhammad will take over the class. Okay, we continue the class. Okay, you know Dr. Jamal, right? You know Dr. Jamal, everyone? Do you know Dr. Jamal?
No.
No, Doctor.
Okay. Yeah. Okay, he's more senior than me. Okay, more senior and more experienced. Dr. Jamal will take over for probably until week 5 or 6, like that. Then I will continue back. Okay, but not to worry, because we have, we are in the same direction. We have a strict guideline to follow, and you don't worry, we discuss everything. And okay, no problem about that. Okay, I just need to take some leave, and after that I will continue starting from week 7. Probably I will continue. So for the class schedule, we have lecture time today, 2 hours, 11 to 1. Yeah, you check your schedule, correct? 11 to 1 for lecture. And on Sunday, it's 10 to 1, I guess. Is it right? 10 to 1 on Sunday for studio. Okay, so I hope you understand the nature of how design class work, how we run the design class. So we have lecture, and we have 2 hours lecture. Okay, it's same like introduction to design, component design. We have lecture, and then we have studio time. And during studio time is when you do your work, your group work, your exercise, and you need supervision. Okay, for the studio time. So because of the Dr. Jamal got constraint, so the studio time on Sunday, he requests to bring it to Tuesday afternoon. Okay. However, it will be the same day as our lecture time. Okay. So not to worry, because the earlier classes, basically we do lecture. Okay. Not yet activities that need much supervision. Okay, so probably Dr. Jamal will only take 1 or 2 weeks of your Tuesday afternoon for the studio. Okay, understand? Understand? He will focus on lecture at this time. Okay, Tuesday 11 to 1. Okay, understand?
Yeah,
Okay. Okay, please respond. You can respond by unmuting or by writing in the chat. Okay, please respond. Okay, so we start. Basically we start today. I will share you my slide now. Okay, can you see this?
Yes.
Okay, I start with some introduction. I cannot record this. Wait. It's okay. All right. So SEMM 4533, is it correct? Right? You guys, SEMM or SKMM?
SK.
KMM.
Okay, sorry. So
SK.
SEMM, yeah, SK. All of you are SK.
Yes.
Okay, I noted. Okay, actually, it's just SE is engineering, K is just the same thing actually. Okay, the contents are the same, just the code different. Okay, so you know what is 4533? What is for?
Fourth year.
What is 5?
Fourth year.
Okay, 4 is for year. What is 5?
Studio. Tak tahu lah.
Okay, actually 5 is subjects in design. Subjects under design. Okay, so we have solid mechanics, we have thermofluid, we have applied mechanics. Okay, we have many areas in our faculty. Okay, and all design subjects falls under 5. So if you see 5 is design courses. Okay, and what is 3? The first 3. Okay, these 3, I believe you don't know, even though you are finally already. Okay, these 3 is the sequence. Okay, if you remember, you start design subject is 1503. Okay, that is the first. The first sequence is 0. And then 1512. 1513. Okay, I think if you SKMM, your introduction to design was 2 credit, so 1512. The second sequence is 2. The third one is component design. And now the fourth subject, with number 3 here. It's the sequence here. You must take all the subjects in sequence. And the last one, you should know what is this?
Credit.
Yeah, okay, this is credit. So the subject is called system design. System design. Okay, what is system design? What you have heard about system design from your seniors probably? Do you have any idea about this subject?
No idea.
Ya ke? Okay.
Maybe same like
design.
design.
Maybe what?
Maybe same like component design.
Oh, okay, not really. I mean, it's the continuity of component design. You took drawing and then you took introduction to design and then component design and system design. Okay, I show you the relations later after this. Okay, to make you understand what we going to do in this class. Okay, so system design. Why is it in final year? Okay, in some university, we call system design as a capstone subject. Capstone subjects. That means this subject will cap everything that you have learned since you are first year up to now, before you graduate. Okay? Capstone subject is the subject that will cover everything before you graduate. Okay? And in UTM, we call it system design. Okay, so you can imagine how big is the scope of this subject. Understand? Okay, so my name is Nurfasiha. This is my email address. Okay, just to introduce myself first. My first degree is here. Any idea where is this? My undergraduate study was here. Just quick guess.
Jepun.
Tokyo University.
Saitama University.
Kyoto.
Saitama.
Okay, yes, yeah, some of you took my class, right? Okay, if you can read this character, this is Saitama Daigaku. Saitama University lah, is in Japan. Okay, if you in front of me, I'll give you some chocolates, for guessing right. but I can give you virtual ones lah. Okay. All right. This is Saitama. My first degree. I did mechanical study here. And okay. And then after I graduated, I worked here with this company. Okay. I start with quality engineer, and then production engineer, and then design engineer. Okay. There are many like hierarchy of engineer actually. Hierarchy. So you should know that in the hierarchy, like at the bottom one is maintenance engineer. Okay, you just imagine oops. You just imagine a rectangle like this, okay? Okay, the one at the bottom here is like maintenance or service engineer. Still engineer, okay? But maintenance or service. And on top here is what? What should be here? In the engineer hierarchy.
Design.
Yes, design, yeah. This is design or consultant. Consultant engineer, okay? On top here. Oops, sorry. Okay. And the rest are in between lah. The rest are in between. So when you go out and work for engineers, as an engineer, you should aim, you should aim the top level. Okay, the top level because you are from a very good, well-known university. Okay, very good university. You should be on top in the engineering hierarchy. That you should be able to do design. Okay, I teach you later what is design, what you should do to become a good designer. Okay, later. Okay, this is my second degree. You know what is this? Oh, you forgot already because we have been online.
YPM.
Okay. Okay, this is my second degree. So my master, I mean, in PTM, to mechanical engineering, master here, and my third degree is here. Any idea what is this? This is a very nice university. You can see here, there. It's so on a hill. This is the university, and from here you can see the port here, and the city in the middle. No idea.
Pasir Gudang.
Is this Pasir Gudang? This is also in Japan, yeah? It's also in Japan. This is Kobe University actually. Okay. I have a story if you want to hear a story, a short story. You want to hear a story about Kobe?
Can.
I know, students like to hear story rather than lecture. Okay. When my first degree, during my first degree, it was in Saitama, it was 97-2001. 97 to 2001, I was in Saitama. I did my undergraduate study. Okay, it was around year 2000. Okay, it was around year 2000 that Japan had a forecast of a very, very big earthquake will happen in Japan. Therefore, because you know Japan, there are a lot of earthquake and tsunami and everything, right? So they forecasted this. It was around year 2000. Okay, actually I experienced a lot of earthquake already, but that time, that one, the forecasted one, they mentioned it will be very, very big, very, very gigantic earthquake. Okay. My question is, the forecast, we forecast, we have some time, right? Time span. It will happen within this period. Okay, how long is the time span? You have any idea? It was year 2000. They forecasted a big earthquake, but the forecast, what is the time span mentioned in the forecast? You have idea? You have any idea? Come on, just any guess of time. Okay, the earthquake will happen within how long? Within how long of time? No idea. Week. Okay.
Minutes.
6 month.
Okay, ada week, minutes, months, all wrong.
1 day.
No, 1 day. So scary, right? Is it
Years.
really 1 day or months? Huh? Years? How many years? Yes, it is years. How many years?
3 years.
2 years.
3 years. 3 years is not to say close, but yeah. Any other guess?
4 years.
2 years, 4? No.
5 years.
5.
No, not 3 but 30. 30.
Wow.
Older than your age. Just imagine that you born today and it's already forecasted that a big earthquake will happen in 30 years. In 30 years. You just born today and you already 30 years at that time. Okay? No, I mean, just imagine that the Japanese who staying in Japan, they don't have any choice to run away or to do anything. They just have to live their life and see what happened. Okay, just like that. Okay, then they don't have the choice to run away. It's 30 years. What can they do? Okay, so that is about the forecast. 30 years, it was year 2000 around that. Okay, a very big one will happen. Okay, then I graduated 2001. I came back to Malaysia. I went Panasonic. I go further study and everything. And then when I wanted to continue with my PhD, of course, because I'm already in love in Japan, I decided to go to Japan again. Okay, but which university should I go? Okay, which university should I go? When I was about deciding the university, then I just remember about the forecast. Forecast, it was in 2000, yeah? I mean, I was there 97 to 2001. I just remember that, and at that time, I just decided to go to Kobe University, which is very far from the area that forecasted, yeah? Very far, very far. I went for PhD 2007 to 2011 actually. Okay, just 10 years after my first degree. Okay, and happened to be that the forecast, the 30 years forecast happened when I was there. If you remember, in 2011. Okay, in 2011, I was in Japan doing my PhD, and that 30 years forecast happened that time. It was about after 11 years lah. Okay, still within the 30 years. It happened, if you remember, 2011, a very big earthquake and tsunami, and also the nuclear station tragedy happened in the northern side of Japan. Okay, do you remember that? You aware of that or not? No. You there or not? Connected or not?
No, doctor.
Not connected or not aware? You're not aware about the 2011 earthquake in Japan? That's the second, I mean the nuclear station incident that happened during that time, the Fukushima nuclear incident is actually the second worst in history up to now. The second, the first one was Chernobyl. 1986, and the second was that one, Fukushima. Okay, you should Google more. You can Google after this. Okay, that's the second worst in history. Okay, all right. So end of that. Okay, a story. Okay, we continue. Okay, I teach. What I teach is course design subject. Engineering design is master subject. Okay, system design, component design, introduction to design, engineering drawing, and I also teach programming and radio attributes. All right, that's about me. Okay, so I stop the sharing first. If you have anything to say, just drop it in the chat box or just unmute yourself. Okay, now we go straight away to the introduction. Okay, before that, about the class. Okay, this is what actually you really want to know. Okay, this is our CI, course information. You can see this, yeah?
Yes, Radin.
Okay, good. Okay, our subject is system design. Okay, so this is the synopsis and the CLO. Do you know what is CLO? Course learning outcome. This course learning outcome. What are the outcome expected for the students to have after completing this subject? Okay, these are 8 items. Okay, 8 items that are listed as the CLO for this subject. Okay, and okay, this is our weekly schedule. As you can see here, for this week, yes, I give you overview, course information, and overview of the engineering design, and also I give you project already. Okay, for this class, we're going to it will be a group project and no test, no final exam, only project. I will assign you a project today. Okay, and then week 2, 3, 4, 5, probably until 6, 2, 3, 5, 6, Dr. Jamal will take over and teach you this. Okay, mostly only did lecture because not yet group, not much of project group yet. Okay, so as you can see here, you will go through the process of design process. Okay, week by week up to week up to end of the class lah, up to end of the class, end of the semester, and you have to do the virtual prototyping, presentation, report. Okay, these are the skills, class presentation, okay, poster, report, project management, costing, thinking, and sustainability. Okay, you don't have to understand this. Okay. Okay. Special requirement is anything that you can use virtual prototyping and drawing. Okay. You can use SolidWorks, CAD. CAD is a computer-aided design. You can use SolidWorks, whatever that you know and comfortable with. Okay. These are the textbook. Okay. These are the textbook that actually not textbooks. We don't have textbook, but these are the references that you may refer. Okay, actually there are a lot of engineering design reference available. Okay, you can refer to any of them. Okay, Okay. All right. If you have any question, just let me know straight away. Okay, now can you see this marking scheme?
Yes, Cikgu.
Okay, this one is actually, okay, you can see here, this the first column is the faces. Okay, what we will do, what you will learn and what you will have to do, and then the course will come that you have to gain, okay, by attending this class. Okay, so these are the things in the first column, that we will teach you during the lecture, and then you will do it for your project. I will give you a project today. You will carry out everything here for your specific project. I mean, you follow this process for solving the project given to you week by week, and basically you will have to report and present your progress basically week by week, every week, because we have lecture and then you go back to your project, discuss and present, and then lecture again, what is the next step, then you go back to your project, okay, discuss with your group, do it and present, and lecture again, what is next, okay, understand that?
Yes.
Okay, good. So this on the right one is the marks. Is quite detail of the marks that will contribute to your grade lah. Okay, the marks distribution on the right. So the main thing in this course is your project. You'll be given a project and you follow all the steps. Okay, you carry out everything and you write report, you do presentation, write report, and final presentation, and then you get marks. And this must be done weekly. Okay, week by week. All right. Okay, if no question, I will proceed to a slide. To my slide. Yeah. Okay, so we start with introduction to engineering design. Engineering design is our keyword, yeah, for this system design class. Okay, so SKMM 4533 system design. Okay, introduction to engineering design. Actually, this one I show you last Sunday. About half of you attended last Sunday. Okay, so I give some brief. Okay, by giving this slide, I will repeat today. Okay. Okay, so you are going to become an engineer very soon. Okay, I guess less than 1 year you graduate and become an engineer. Right? Okay, now you as a student, I mean you guys, actually in the world of engineering, okay, that you're going to enter soon. I mean, yeah, you study engineering, you are there already. Who are you and where actually you are? Okay, to make sure you understand where you are right now. Okay, of course you are a student and you are studying engineering. Okay. Okay, so first of all, engineer is a professional job. It's a profession and it is a professional profession. Okay, it's a professional profession. It's not like profession that, you know, there are many like you selling things or whatever, right? That is not professional things. Engineering is a professional job. Okay, so what is a professional engineer? Okay, to become a professional engineer, actually these are the definition, definition of professional engineer. First of all, you must be qualified. You must be qualified. That means that you must complete your study, learn everything required, needed to become an engineer, and graduated successfully and got certified. That is what meant by qualified. And then the second one is engaged. Engagement means that you work in that area. Not that you learn engineering and you work as a lawyer, then you want to claim yourself as a professional lawyer, cannot. Okay, so you must qualify and engage in the area of engineering. And the third one is the most important, that you serve the society. As an engineer, you serve the society. Okay, all right. What is serving the society? Okay, what is serving the society? How and does an engineer serve the society? If you can see here, this is a theory, a knowledge. Okay, discovered by a researcher or a scientist. Okay, this is a theory about magnetic field that discovered by researcher or scientists. People who do research or do research and discover knowledge. Okay, when you learn engineering, you learn all the theories. You don't discover theories, you learn the theories, and then you apply everything that you learn to create something. Okay, to create something. So using this concept, this is maglev, this maglev. How fast this maglev can go? Anyone know? How fast this maglev can go? This is a very fast train, okay, that run by the concept of maglev. Okay, this is very, very fast one. Okay, and engineer create this. Engineer doesn't do this. Engineer create things. Okay, create things to help the people in the society improve their life. Okay, so they want faster transportation. Faster transportation. Then you create this using the theory that you learn when you study. Okay, and this also using the magnetic concept. This also. Okay, so this is what engineers do. They create things that never exist before. Never exist before, This thing never exist before. An engineer make it possible, make it exist. Engineers do this. Okay, how actually? How actually engineers do this? Create things. Create the something that never existed things. How? Okay, so okay, to create something to help the society, we must start with a need, problem. Like just now, the society want a faster transportation. Okay, a faster vehicle. So, what society want is the problem or the need, and you have to solve the problem, solve the need as an engineer. Okay, so we must start, everything must start with a problem or a need. Okay, I want everyone to give answer. Okay, what is this? Do you have any idea what is this? Have you used this? I have experience using this when I was small.
No.
You can type on the chat or
Sure.
not sure. You can type on the chat or you can, conteng-conteng on my slide also. Open for annotation. No problem. Okay? Not sure. No idea.
Pressure cooker.
Pressure
Salai.
cooker. Wow. Salai. Oh, salai. Interesting example I might consider for my other class. Okay, this is not salai. This is actually conventional way of baking cake or glue inside it. Because when we bake, we need the heat at top and bottom. Okay, so conventionally, okay, old people, they do like this. Okay, they have heat at the bottom and heat on top of that what lah, and they cakes inside for baking. Okay. All right, this is a very old way of baking. Okay, now can you tell me what are the problems faced here? The smoke, okay, not good for health. What else? Oh, okay. Before that, please, I have to tell you, okay, for my class, everything, if you want to ask or discuss anything, please, as much as possible, discuss it in group, not personal, don't PM me. But if you have anything you want to ask in the group so that we can share with everyone. Okay? Also during the VC also, during our class also, please type the chat, not privately, but in the common room so that everyone can see and learn together. Okay, come on, quickly. You can see straight away. You just let me know. You can write in the chat, or you just unmute yourself, or also you can write on my slide as well. Here, there's smoke here, smoke here.
Heat not
And what
consistent.
else? Yeah, heat not consistent. You have to control this. Not consistent heat. Dust. Correct. What else?
Safety.
Yes, safety. Looks dangerous also. Safety things. Here. Okay, and so you have to move this coal on top here by hands. Okay, it's so not safe. What else?
Tedious.
Yes. True. Okay. Yes, you have to set the coal, everything.
Harm to environment.
Yes, harm to environment. How about the? Maybe someone have answered that. The temperature control. The best temperature you want for your cake. How do you control that? And time also. What else? Space here. I can see a space here. Okay. So there are problems. When there are problems, there are needs. Okay. And then when there are needs, there is when the society need an engineer to solve this. Okay, so if you're given this problem, how you want to solve this problem? How are you going to solve this problem? Come on, future
Make oven.
engineers. Oven, yeah. Oven is a solution, one of solution. Okay, so I show you a picture of oven that you can bake a cake. Okay, with all the problems you mentioned just now solved. You can control time, you can control temperature, no dust, no harmful, no, it's safe also, it's not tedious, and many more. Okay, all the problems are solved using oven. True, eh? Okay, that is just example of solution. There might be other solution to solve that problem just now. Okay, but at this moment, what we have in our life, okay, what the engineers so far have invented. This oven has been invented by engineers to solve this problem, the original baking method. I mean the traditional, conventional baking method. Okay, so this is the problem and this is the solution. Remember that keyword, yeah? Problem and solution. And from here to here is what? What is there between this and this? It is actually the engineering design process. Okay, this is the very, very big keyword for you to understand. The engineering design process. Okay, the engineering design process. When we say it is a process, there must be a process. There must be a start and there must be an end. And there must be something in between because it is a process. Okay, not just that, okay, you see a problem, okay, and then suddenly an idea come and you just produce the idea. We don't know what's the idea, but if you just straight away see a problem and straight away you take a paper, you do sketching, you sketch your idea and you give to the manufacturer. Manufacturer would manufacture your idea and that's the solution. That's not design process. Okay, design process is a process that you have to know, to understand, to go through before creating a solution. Okay, later I tell you why you need this process. Why don't you just solve it? Okay, I don't know, because just now you answered oven because you already know oven. But as I mentioned, design engineers invent, create something that never exists. That never exists. Just imagine that an oven never exists in our life. Can you answer oven as the solution just now? Of course not. Surely not. Okay. So you need to go through the design. The engineers actually need to go through the design process to come up with an oven. That is the new idea. Okay. That actually now already exists in our life and we accept it, we know it. So we take it as a concept of oven. But I also mentioned just now, an oven is probably just one solution. There might be many more solutions to solve this problem. It's just that the solution is not yet invented. You understand, yeah? Another example is like the fan, of course. Okay, fan. For so many years, for maybe 100 years, okay, people, we are using a blade to chop the air, okay, to chop the air, to make the air move, okay, and give us some wind effect in the room. That's how the fan works so far. That is the fan. So when we say I have problem, the room is so hot, okay, the solution is a fan. That could be one solution. Actually, the fan is already exists and engineer have invented that concept. Okay, what are the other concepts that can solve the problem? Okay,
Aircon.
yes, aircon is another one. True. Okay, that is another solution for cooling the room. Okay, and yes, there's another one that not so recent lah. Maybe 10 years already, 10 plus, 10 years before, been invented by another engineer. Okay, the concept of fan, but not using blade. You know the bladeless fan, right? Bladeless fan are invented by the company Dyson. Okay, that is just another solution that just invented, just discovered by engineers. Okay, so we don't say okay, we accept fan because when we born we see that already. Okay, there is something that already in our knowledge, already in our life. But actually there are many more solutions that could exist that just not yet invented. Okay, that is why and what actually engineers do. Okay, to find solution. And as the hierarchy just now, okay, the hierarchy of engineer just now, okay, here is maintenance and service and here is design. So the design engineers is those who create the new concept, who discover a new way of doing things. Okay, the bladeless fan, new way of cooling the room. Okay, other than aircon and fan. So I want my students to be here. UTM graduates must be here. Okay, not just doing the service or maintenance. Okay, let other university graduates do this. Okay, our students must have the quality of doing this. Okay, all right. Next. So you are clear about the role of engineers already, eh? You are clear. Okay, this is the thing. Okay, this is the engineering design process. We start with problem, we end with solution. Okay, problem, solution. And this is the process. And I want to show you, okay, the green one is what you learn during the first year. Okay, first semester, first year, engineering drawing. Okay, and the blue one is what you learn in your introduction to design class. Problem and conceptual design. What is conceptual design? Is the idea actually. Idea of cooling the air. Okay, so we have blade for chopping the air, we have aircon, and we have bladeless type. The bladeless type concept is, I forgot how the bladeless type work, but it's just the concept of moving the air also. Okay, and any other concept. Okay, the concept design. So you stop at conceptual design for the introduction to design, and then if you can see here, this is first year, this is third year. So in between of this blue and red, there are space of times. There are times, like second year, 1 year and a half here in between, for you to learn all the necessary knowledge, engineering knowledge, like your solid, your vibration, your statics, dynamics, fluid, and everything. Okay, all engineering, all core knowledge that needed for you and then you continue with component design. You have all the knowledge first, and then you will be able to do this detailed design. Okay, you'll be able to do this detailed design that you learn in component design. In component design, I guess you remember what you learn here. You learn about bolts and nuts and welding and everything. Okay, and you seriously need the knowledge of solid static here, right? And then the yellow one is our system design. That's what I mentioned just now. This is like a capping. Before you graduate, you need to cap everything. Okay, so all the knowledge are here and component design here, and you understand, you know how to create concept here. Okay, and when you have the solution done, you know how to communicate your idea. Okay, how to show your idea by using engineering drawing to outside people. Okay, so these are the things that we're going to do for this subject, this semester. Okay, so it will cover everything. This will cap everything. Okay, it sounds not that difficult actually. You just given one project, you work in group also, okay, to solve the problem. You just follow all the process here. But you must know, you must understand that you need to have all the knowledge. I mean, you are a final year student. You learn a lot of things already, and you have to apply your knowledge, your skills here to solve the problem, the solution that will be given to you, your group work. Okay? No test, no exam, just that project. Okay, clear? Are you clear? Are you clear?
Clear.
Yeah.
Okay,
Clear,
good.
Doctor.
Okay. Oh, this one, the one is for master, for master course. Still we use 5, 5 design subject. Is broader than this lah, bigger than this. You need to add some research element. Okay, so system design is this yellow. Okay, clear? Alright, so end of the introduction of part 1 introduction. I go to second part of introduction. Do you have any question? Okay, no question. We quickly go to the second part of introduction. I need you guys to understand this very well, because starting next week, Dr. Jamal will start teaching you the first step that you have to do in solving the problem. Okay, this is the second part of introduction. Okay, what is professional engineer? I guess I just mentioned to you just now, so you remember there are 3 attributes. You are qualified, you are engaged, and then you serve the society. That is a definition of professional engineer. Okay. All right. Anyone want to answer this? What is design to you as a professional engineer? You must know what is design. You're going to become a very successful design engineer. Okay, so what is design to you as a professional engineer? What is design? What is designing? Come on. Come on. You can write something on my slide also. There are a lot of space here. Yeah. Design. What is design?
Doctor, can I try?
Yes, of course.
For me, I think design is a specific drawing done by the engineer for any product, including precise calculation of a precise measurement. Okay, I think that's it.
Okay, all right. I can accept that. And this is another answer to create something also can be accepted. Okay. All right. All right. So all those are correct. It's designed to create something. Yes, to plan to solve problem. That is close. Very close. To the actually those are all correct. Okay. But in short, in very short term, okay, design is solve problem. Okay, to solve problem. To solve problem. But to solve this is actually you have to create lah. To create. Okay, to create something. And to create something, okay, all your answer is here, yeah, I explained. Okay, to solve problem. So society has problem, you need to solve. To solve that problem, you have to create something. Because if the solution already there, you're not solving anything. Okay, someone has solved that. Now, as an engineer, you have to design, you have to solve. And in order to solve the problem, you have to create. And to create the solution, you have to do all the process lah. Okay, including to draw with detail. Why you need detail? Of course, you cannot just have idea and you just manufacture it. Of course, you need to make it detailed. You want to create an oven, for example. Okay, you just tell them I want to create an oven. Cannot. You have to produce that solution in very detail. What is the material? What is the working principle? What is the dimensions? What is the configuration? Everything that you must do in design. Okay, so in the big definition, it is to solve problem. Okay, in order to solve the problem, you have to create something. And to create something, it must be done very, very precise, very detailed. Okay, I'll tell you why later. Why not we just see the problem and solve it? No, you need all those detailed things. Okay, to that. All right, next slide. What is design process? Okay, design process is, as I mentioned, this is the process. Okay, this is the process. So it must start with, it is the process of solving problem lah. It is a process of creating a solution to a problem. That is design process. Okay, all right. So if we see, look at the definition actually, the process of devising something, solution to meet need, the desired needs. Okay, because we want to solve the needs. Okay, and to do this, you must have the knowledge in science, mathematics, and engineering. You need to have the knowledge. Why? Without the knowledge, you cannot create, without all those engineering knowledge, you cannot create a maglev. You cannot create an oven. Okay, no way you can do that. Okay, you need to have all the knowledge that you learn during your study. Okay, next. Okay, this again, I repeat, this is the process. Okay, start with problem and solution, and you understand that there are two parts. Okay, remember, there are two parts in engineering design. Okay, we have problem and solution, and in between there are two parts. One is conceptual design and one is detailed design. Conceptual design is where you need to create a concept. Okay, how to do this? Okay, if you want to create something to cool the air, okay, to cool the air without using blade. So how? What is the concept? Okay, you want to use the concept of moving the air, but by using maybe differences in pressure. For example, room pressure, you use the concept of pressure, to make the air move naturally. When the air move, then the room will be cool. Okay, that is another concept. Chopping the air is another concept. Okay, okay. So this is the first part. When you done with the first part of concept, then using that concept that you decided, you go detail. You go detail means you decide the material, you decide the dimension, you decide the detail principle, working principle. You decide the dimension, everything during the detail design. Even you decide what bolts, what fastening method you want to use. You want to use bolt and nut, or you want to use rivet, or you want to use welding. Okay, if you want to use welding, what is the configuration of the welding? Okay, all those in detail design. Okay, you have the solution here, and then you do detail design before you come up with the final solution that you want to propose to your boss or to your manufacturer. Clear? All right. Okay, this also repeated one. You must understand this first. Again, we have two parts: conceptual design and detail design. Conceptual design, you decide on the concept, and the detail design. Okay, in this course, we will do conceptual design up to week 7 like that, before the semester break. We must finish this part. And the second part, we do this detail design. Okay, up to the end of the semester, you will, we expect you to have the solution, the fixed, the rigid solution, plus the drawing. Drawing is easy. If you design using SolidWorks, you just straight away can produce a drawing. Okay? Clear? So this is second half of the semester. This is first half of the semester. Okay. Before that, before I explain more. Okay. Why is it so important to have design process? Okay. First of all, okay. First of all, as I showed you before, there are two stages here. Okay, conceptual design and detail design. Okay, conceptual design and detail design. These two stages, okay, is very critical. During the concept design, what is required for an engineer to be able to do this? The conceptual design. Yes, it's very important for an engineer to have a good imagination, creativity. Okay, because you are creating a new concept that never exists, never created before. Okay, you need to be very creative here. And the second one, for this part, okay, it depends on the project that you are working on. You need a lot of scientific knowledge, engineering knowledge. Okay, so the first challenge is, first, you need the design process, involve scientific process. That you need to have all the knowledge. You need to be graduated. You have to learn a lot of things and certified. You have to need the knowledge. Plus, you need creativity. These two are very different things. Okay, right brain, left brain. Okay, you need to have both to be able to stay on the top hierarchy of the engineers. Okay, and then this is the definition of engineering design process. You need to have knowledge, you need to have imagination or creativity. Okay. Yes, if you can see the notes here, many tools are available. Of course, there are many tools. However, since design is also a creative process, okay, we still need the designer. We cannot rely on the tools or software. We need the designer's brain, okay, for creative process. And also, no matter how good is all the other process, if the product is poorly designed, the ultimate product will still be a bad idea. Okay, this is a Chernobyl disaster that I mentioned just now. The worst in history, the worst nuclear explosion, disaster related to nuclear station, the worst in history so far. The second one is Fukushima, was Fukushima in 2011. That's the second worst one. The first one is the Chernobyl. Okay, you can Google. Okay, you can Google. I'm giving you example of disaster that happened due to a bad design. Who created the nuclear station? Of course, a designer. Okay, and because of design efficiency, this very bad event happened that killed so many people, and the effect still continue up to today. You can Google. All right. So the second one is also in 1986. Okay, this is the Challenger disaster. Have you heard about Challenger disaster? This is a very famous incident that people make movie of this, movie and documentaries and books, and you can find a lot of information related to this regarding this event. Okay, the space shuttle. Who designed the space shuttle? Of course, the designer. Some designers lah. Okay. Only after 73 minutes the takeoff of the space shuttle, it exploded. Okay, you can find this live, the explosion live recording on YouTube. Okay, I have it, but I cannot show you right now. Okay, this also related to the design, the failure of ring design actually. Just a small ring that control some temperature, okay, inside the space shuttle, and this is what happened. Okay, can you imagine how critical is the work of my designer? Okay, just a small ring seal, okay, on its right solid rocket booster, and this is what happened. Okay, you spend time, money, and everything to to make this space shuttle, and then it's just exploded like that and kill everyone inside. Okay, there's engineers' responsibilities, designer responsibilities, and this also another thing, 88, okay, the loss of cabin roof. Okay, the causes is if and design of the aircraft. Of course, this is design aircraft, and that could happen. Okay, I'm showing you just, this is taken from one of textbook, all the, this incident happened, that happened due to design. Okay, not other things. There might be other things, but part of them are design. Okay. All right. So these are some examples. And okay, the next one is, even if design is technically success, no fault at all, perfectly done, still many designs fail to achieve the goal. You know, this happened when I was working in Panasonic. I was in design department, and design department in Panasonic many years ago. Okay, that time what we did was we planned for future product 5 years ahead, what people in Malaysia would like to buy, would like to use. Then they have the not yet existed product in Malaysia, but we plan for 5 years ahead and 10 years ahead product. We plan for what we're going to market in 5 and 10 years ahead. That was what we do that time, when I was in Panasonic in the design department. That what we did. Okay, so the things that not yet exist in Malaysia, basically, mainly, okay, so we have to plan for that. So we plan to produce a lot of things. Okay. We plan. We do research. We do research. We see the trend of people, of market, everything. Okay, and we plan for many products. You know, Panasonic, they produce a lot of products. Okay, home appliances product. So we plan, and okay, one of the product, it was electrical broom. Electrical broom. One of the product that we plan. Okay, electrical broom didn't success lah. Didn't. Okay, people in Malaysia up to today also not using electrical broom. Does not prefer electrical broom. They prefer vacuum cleaner or conventional way of sweeping the floor. Okay, so that is one example of a failed design. Okay, I left Panasonic already, so I don't know why people in Malaysia cannot accept that. Okay, it cannot, it doesn't happen, it doesn't become a trend in Malaysia. Okay, that is what happened. Not in the case in the other countries. In other countries, I don't know. I'm not sure about that because I left Panasonic already. But that is, I give you an example of a failed design. Okay, that's from my experience. Okay, actually, why that happened? There are a lot of factors that contribute to a failed design. Okay, other than the difficulties that you need to have knowledge, that you have to have creativities and so on. Okay, it is inherently essentially difficult. Okay, design is not an easy thing to do. Okay, you can easily make mistake and cause many troubles, and also it's not easy to do also. Okay, so to conclude, okay, why is it difficult? First, you have to have the knowledge and creativity. You need both. Okay, maintenance engineer doesn't need creativity. Okay, or production engineer doesn't need that. Production engineer just control the production. Quality engineer just need to make sure the quality is, controlled. Okay, but for design engineers must have this, must have knowledge and must have creativity. This is only for design engineers. Okay, and also designers must be able to predict the future. This is like what I mentioned just now lah. Okay, we plan for 5 years ahead, 10 years ahead. How actually to predict? Okay, sometimes we fail here. You must be able to visualize things. And the last one is people are different. The preference of people. Sometimes we don't know why. When that time comes, people don't want to buy it, don't want to use that product. Okay, the design is perfect already, but just people does not prefer that. Okay, all right, that is the challenges in design. And because of these very difficult challenges, okay, because of those, okay, therefore, a systematic design process is important to guide the designer to achieve his or her goal. Okay, because it sounds easy. You have problem, you want to solve problem, just solve it. Okay, but because of the challenges that I explained to you just now, okay, you must understand that this process is not easy, and therefore to assist, to guide you guys as a designer, okay, you need a guideline. Okay, and we call it a systematic process. We need to have this engineering design process. We need to learn this very seriously. Okay, later you become an engineer. Okay, you need to do research and development. You develop a product, you do design a new product that never exists. You need a guideline. Okay, not just hoping that something just come to your mind like that. Okay, alright. So this is the like like concluding, like a conclusion to you why this subject, how important is this subject, how important is this design process. Okay, so back to the design process. Systematic design process. There must be a systematic design process. So when we call it systematic, there must be a process, a guideline lah. Okay, this is from the design process. This is taken from one textbook. One textbook. As I mentioned just now, there are many reference that you can refer to understand design process. Okay, in all the books, they must be showing you kind of flow chart or diagram like this. Okay, the process. You can see the process. There must be a flow. Okay, this is taken from one textbook. Okay, this is from another textbook. Okay, if you can see here, clarification of the task, conceptual design, embodiment, detail design. Okay, this is from another textbook. Okay, this also from another textbook. Okay, there are many versions of this flow chart. The guideline, the systematic design process, because people doing research on this, right? People doing research, so they propose this, and this, so on. Okay, but if you see, okay, just now, first one. Okay, this one. We start with problem recognition, information sets, synthesis of configuration, and going downwards. Design analysis and evaluation, experimental. Okay. This one also conceptual design, embodiment design, and detail design. And this one also, I can see here, we have produce concept, solution concept, embodiment, detail design. Okay, basically whatever you can see in the textbook, okay, basically they, even though the flow chart are different, but the idea is always the same. It's always the same. It's like this. Okay, to make it very simple to understand. It's like this. You have problem and you have solution, and in between there are two parts that you have to go through. The first one, create the concept, and then you detail the design. These two parts are very important for you to understand. Okay, so in this conceptual design, there are many steps inside. And for detailed design, so there are many steps inside. Okay, you may refer to any books, but you must understand the flow is this way, like this. Okay, all right, so this is what we will do in this subject. Given a problem, and then you conceptual design, you do the conceptual design, and then detail design, and come up with solution and present solution. Okay, end of the introduction. Any question? Anything you want to ask? No.
No, Doctor.
Clear, You must clear with this first before you proceed. Because if you're not clear with this, you just like, you do every week, you just follow the lecture, then without any idea, it will be difficult for you. Okay? Alright. So the last thing and most important thing actually to share with you. This is the last thing for today. Okay. I want to give you, can you see this? My Microsoft Word. No.
Yes. Yes.
Yeah. Okay. This is your project. the problem that you have to solve. Okay, I show you, we discuss later. I will show you the file later. Okay, so I read this first. JZ Industry provides innovative supply chain. This is taken from industry. This is actually the actual request, actual industry and actual request from them that we design panel have received recently. We're working on it, okay, on this project. Okay, so this company provides supply chain. You know, supply chain, you learn about supply chain, yeah? For SME, small and medium enterprises, or larger companies in Malaysia to supply industrial supplies. These are the examples lah. They supply like glove, fasteners, and nuts, abrasive cutting tools, other consumables. They supply a lot of consumables products for industries. Okay, the company helps local manufacturers to grow in profitability by increasing their productivity. So JZ is a supplier of products, of these small products that required by manufacturing companies. Okay, and also it helps manufacturers to grow in profitability by increasing productivity through those. Okay. And on top of supplying the items here, okay, in this figure 1, the JZ company also provide vending solution. As shown in figure 2, this one, figure 2. You can see this is a vending machine, a vending solution that give you all the items lah. Okay, so they provide this to the companies, to the manufacturing companies. Okay, so the details you can read here. Okay, this is one of their machine. This is one of their machine. The vending solution, they call this vending solution. So these are the items inside. Okay, this is the problem. The problem is that with the current helical concept, okay, if you can see here, it's like a vending machine. You choose, okay, you enter here in the panel here. Okay. You enter what you want to take from this machine, enter the information, and the helical concept is this, like the helix, helix that will drop your item down here. Okay, drop the item down here. So the problem is with the current helical concept of supply that apply in the machine, items, okay, there are many types of items here, easily got stuck. It's not like the can or the drink vending machine that the shape is all the same, the size is about the same. Okay, there are many shape, many weight also varies, the shape also varies, the size also varies, and it's difficult actually. The items easily got stuck. Okay, and thus, therefore, the items easily damaged. They need to do a lot of maintenance, maintain the machine. Okay, and the machine also easily damaged. The items also easily damaged. And to prevent this, okay, the staff of JZ Industry who provide that machine, okay, who serve that machine to the companies, to the manufacturers, the specialists, actually they need to replenish, okay, to replenish or to top up the item inside. They decided to pack each item with plastic to avoid the damage to the product. Okay. This process, however, incurs additional material, additional time, additional labor cost. Okay, and it is certainly not cost effective. And as for the environment concern, the process of using plastic packaging must be avoided. Okay, this is the problem. This, you have to understand this. Okay, because of the current helical concept, so they face this problem that the items and machine is damaged. So to solve that problem, they pack the items one by one. Each of the items they pack. However, the other problems also came up, emerged. Okay, it's not environmental friendly. It's not good for environment. It's will cause more for material, time, and labor. Okay, so that is the problem given from the company to us. And as a design engineer, you and your team in a group are required to design a branding solution with new concept. You want to change the helical concept into new concept that can supply all the items smoothly and safely without the need to package the items one by one. Okay? And the machine also, the mechanism that you propose will be integrated with the control system. I mean, they have the control system. If you see in the machine here, this is the control panel, and this control panel is connected to the control system, where all the orders are managed, all the inventory are managed through using the system. You don't have to design the system, but you have to understand the working concept of the system and how you plan to connect, to integrate your idea with this system. Okay, you don't have to do this to create the system. The system is there, but you must understand that you have to integrate your mechanism with the system. Okay, that's all you have to do. But please, at this stage, I know all students are normally like this. Given a problem, then you straight away have the solution. Oh, I want to do like this, I want to do like this, I want to do this like this. Okay, stop thinking about that. Stop thinking about solution. It's not yet. You remember that there are process that you have to learn, and that process will help you, will assist you in creating the best solution for this problem. Never think about solution yet. Okay? Alright, and the rest are about the report. For the report, this is what you're going to do. Basically, this is the process that we will go week by week. And this is also what you have to do week by week. And this is also basically what we will evaluate you and basically what you have to put in your report. Okay, we just try to understand this. Okay. Alright, so I will share this in the group, probably in the e-learning also. I seldom open e-learning, but yes, I will share. I will have time to upload in e-learning also. Okay, and I will communicate with Dr. Jamal. Dr. Jamal, I will give to Dr. Jamal your list, group member. I hope that is final. And I think that's all for today. Anything you want to ask before we meet again? Probably after in week 7, maybe. It depends on my health situation. Okay, because starting next Tuesday, not Sunday. Starting next Tuesday, this time 11, Dr. Jamal will take over. Any queries? Anything you want to ask? I will add Dr. Jamal in our WhatsApp group also. Okay, so you clear, guys?
Yes, Doctor. So far, no question.
Yes, good, very, very good.
Clear, Doctor.
It's easy, right? You agree? Can you agree? It's easy to understand, easy to understand.
Easy to understand lah. Tapi Z tu belum pasti lagi.
Hard to do, right? There's a lot of work to do. Correct? We meeting 5 hours per week for 3 credits. So that shows that only 2 lectures and 3 hours of your hard work that you have to show. Okay? Understand? That's the meaning of
doctor,
3 credits for 5 hours. Yes.
Okay, about the design, ada calculation ke kena buat?
Sekejap Calculation kata calculation. Oh yes, calculation during the detail design. It depends on the project. For example, if you do, it depends on the project. What calculation needed? Normally, you will need a stress calculation, the bond misers. It depends on the project. As I mentioned, you need to apply whatever you learn, depending on according to the project. What is required knowledge for the project, then you do that. Okay, like for example, you want to drop. Do you want to just drop the item kan? Right. So you have to do the analysis on the dropping mechanism like that.
Yang calculation tu part analisis kan doktor? Bukan?
Yes, yes. During the analysis, not that I mean you have to show that your idea will work fine. To show that, you have to show some calculation or simulation to show that your mechanism will work fine. Of course, you need that. Understand or not? Okay. In terms of design itself, there are just a little calculation like the decision matrix, very simple calculation. But the hard calculation you might need when you want to do the detailed analysis on your mechanism. And what you need for that is seriously depends on your idea. Okay? Any other question?
No.
Okay. Okay. So if no question, now I am sharing to you the last of the last but not least. Okay. This one, your attendance code. Okay, so you can scan this. Basically, we finished today. Okay. If you have any question, you just can ask in the chat or in the WhatsApp group, or just unmute yourself. You can ask. If no, you just scan and you can leave the class already. Yeah, see you in few weeks later. Okay.
Thank you, Doktor.
You're welcome.
Terima kasih, Doktor.
Sama-sama.
Thank you doktor.